Well, we're not going to be using a protractor during online learning this year. I wish we were because it's a lot of fun. But I wanted you guys to actually see how to measure angles and how to draw them with a protractor, just in case you have one at your house. What I have in front of me is my big protractor that I would normally stick to the whiteboard when I'm showing you how to measure angles. Now, an angle is really just a part of a circle. So you can think of an angle sort of like this. Have you ever gotten a pie or pulled a pie out of the oven, maybe on Thanksgiving or Christmas or sometime when we have pies? And when you've thought about the size piece you want, sometimes you might think that you're really hungry and you want to cut a really big piece of that pie. Sometimes you think, I'm not so hungry, I think I just want a little bit. And that piece of the pie that you cut out is going to have an angle at the small end of it. And as you probably know, and as we've been talking about, angles can be lots of different sizes. We can have right angles, acute angles, or obtuse angles. And when we talk about measuring angles, what we're talking about is really measuring a little piece of a circle. And so that's why you can see on my protractor that it is exactly half of a circle. I could turn it upside down like this, and if I had two of these, I could put them together and they would make a complete circle. And a complete circle is 360 degrees. Half of a circle is a straight angle, and we've already talked about this one. A straight angle is 180 degrees. Now, when you look at this protractor, you can see that there are different measurement amounts or different numbers all the way across the protractor, and you can see that they come in pairs. And this reasoning is because sometimes we measure circles that open or angles that open this way. Sometimes we measure angles that open this way. And so you have to be able to read the angle measurement depending on whether your angle opens from the left or whether it opens from the right. So that's why we have these different numbers on here. Now, this is where you have to use your common sense. And you have to use what you know about angle measurements in order to figure out what makes the most sense in regards to which number you choose to measure your angle. So let's talk about what that looks like in real life. So I'm going to get out our book that we're not using this week. If you want to do this with me, you certainly can. This is lesson 16, and I want to show you how I would measure a couple of these angles. Now, my great big protractor is great to use on the board, and it certainly could work right here, but it's so big that I've decided to use a small one. And this is just one that I would have from school if we were working at school. And you may have a protractor that looks like this too at your house. I want to first make sure that I'm not reading my protractor backwards. So if you look at this, you can see the numbers are backwards. So I'm always going to turn it around. And then I am going to put this little point right here. I can actually see a set of perpendicular lines. This little point is going to match up with the vertex of my angle, just like this. Let me just zoom in so you can see this. So I'm going to make sure that the vertex of my angle is right there in the middle of this little point. And I also want to make sure that the bottom ray of my angle is lined up with the line on the bottom of my protractor. So this is probably the most important step in measuring an angle, because if you went over here, you would get a completely different angle measurement than if you went over here. It'd be kind of like going to the doctor and having them try to figure out how tall you are. And if they don't have the bottom of that ruler on the floor with your feet, then they haven't gotten a correct measurement of you. So we want to make sure that we set everything up properly. So once again, I'm going to put this little point right on the vertex of my angle, and I'm going to line up the bottom ray of my angle with the straight line on the protractor. Then this is what I'm going to do. I'm going to start at the 0. And I'm going to choose this side because my angle is opening this way. So I can imagine that this angle closed down right here and opened up here. So I'm going to use the measurement on this side. Now, when I first look at this angle, I'm thinking to myself, what kind of an angle does this look like? Does it look like an acute angle, an obtuse angle, or a right angle? And hopefully you're thinking to yourself that this looks like an acute angle. And so I'm going to write the word acute inside of it. And I know that an acute angle is going to measure less than 90 degrees. And this is really important because when I look at the numbers that the second angle's ray passes through, I've got two of them. Let's see if you can see them. I can actually see that this ray is passing through the number 120 and the number 60. Now, I have to think to myself, which one of these makes sense? If this is an acute angle, then that means that this angle measurement has to be less than 90. And 60 degrees is less than 90. I can also imagine that this angle closed up. And if I were starting to measure it, I wouldn't start here at 180. I would start here at 0. So I would think, starting at 0, let me trace all the way up to 160. People get confused, and this is where most people make mistakes when they're measuring angles, because sometimes they'll choose the incorrect measurement. I don't want to do that here. I already know that this is an acute angle. I know my two choices are 120 or 60, and so the one that makes sense, that's an acute angle, is 60 degrees. So this is a 60-degree angle. Now let's see what it looks like on this one. All right, on this angle, I can take a look at it, and already I know that this angle is going to be an obtuse angle. And I'm going to use what I know about angle measurements to help me. This angle has to have a degree measurement that's greater than 90, but less than 180, because 180 is that straight angle. So let's try this one with my protractor. I'm going to match up the little point on the center of my protractor with the vertex of my angle. I'm going to line up the line on the bottom of my protractor with the bottom ray, and then I'm going to come starting over here again, and I can see that this ray is passing through these two numbers, 50 and 130. And so once again, I'm going to remember that this is an obtuse angle I'm measuring, and obtuse angles are greater than 90 degrees. So that means that the measurement that I choose has to be the one that is greater than 90 degrees. And so this angle measurement is 130 degrees. It's really important that I choose, and I go ahead and I get my brain in gear thinking if my angles are going to be acute or obtuse. Well, let's take a look at another couple of these. If you're following along with me, in your book, you've got the problem set, and it's asking you to use a protractor to measure the angles and then record the measurements in degrees. Now, you might be thinking, hey, oh, wait a second, Miss Isley. This is kind of weird because these are small little angles. What do I do? Well, remember that these are really just line segments, and I can continue drawing those lines out so that it becomes easier for me to measure with my protractor. I certainly want to do that. So I'm going to do that for this one, and then I think I'll do it for one of these. Okay, now this one is different from the angle that we measured on this page. And what's different about it is the way that it's opening. This one, you can imagine, is opening to the right side, and this one is opening to the left side. I'm looking at this, and I can already tell that this angle is acute. It is not 90 degrees. I learned that last week. And so that means that whatever the measurement is, it needs to be less than 90. So I'm going to make sure that my protractor is on the correct side, not on this backward side. I'm going to match up the vertex of my angle. All right, so I'm going to look at what it goes through. Well, first of all, I can see that it's going between 30 and 40 and 150 and 140. Now, which one of these measurements would be an acute measurement? If you said 30 and 40, you're correct. But now, which one is it? What am I going to do? Well, this is kind of like a number line. Any measurement tool with numbers on it is really just a number line. So I'm going to look, it's between 30 and 40. It's closer to 40. And here's 50, so I know that I'm going to start at 30 and I'm going to begin measuring this angle. Well, if this is 30, halfway between 30 and 40 is 35. Now these little lines on my protractor are really going to help. So each one of those lines is going to be 1 degree. So if I'm at 30, 35, I've got 1 more degree, 36, and another one, 37. So I believe that this angle is an acute angle that measures 37 degrees. And let's take a look at this one. I don't know about you, but I'm thinking this looks awfully like a right angle. So let's find out. This angle is way too small for me to measure perfectly with my protractor, so I'm going to do what I did before. I'm going to just make this angle have bigger rays. Now, this does not change the degrees of my angle. Making the rays bigger does not change the degrees of measurement inside my angle. A right angle, or whatever this one is, I think it's a right angle, could be this big and it would be a right angle, or it could be this big and it would still be a right angle. So once again, I'm going to measure. I'm going to match up the middle of my protractor with the vertex of my angle. I'm going to line up the bottom ray with the bottom of my protractor. And boy, look at this. I can see that this ray goes straight through the 90-degree mark. So this is indeed a right angle. And it is 90 degrees. What about this one? Let's just see what happens if I measure it using my protractor and I don't draw out the rays. This one looks smaller, so I might think to myself, well, this one is 90, but this one is smaller, so it can't be 90. But remember, we're not measuring how big the angle is. We're measuring the distance between the two rays. We call that the arc. That's what we're measuring. That's the measurement of an angle. So let's put this one down. Boy, I don't know if you guys can see this. I'm hoping you can. I really want you to understand this. As I line up these two rays, this ray is actually hiding under the line that goes through 90. So this is also a 90-degree right angle. So once again, it doesn't matter. I could have a right angle that has rays that are 1,000 feet long, but as long as the angle between the rays was 90 degrees, it would still be a 90-degree angle. So both of these are 90-degree angles. Even though they look different sized, it's what's inside the arc that counts. All right, now let's talk about drawing angles using a protractor, and that we would have done in lesson 7. So I'm going to come over to lesson 7. If you want to do this with me, there's a lot of good stuff in your book. Unfortunately, we don't all have protractors, and this is hard to teach when we're not in school. But if you've got a protractor at home, I encourage you to do these along with me. All right, so I'm going to take a look at this one. This one is telling me I'm going to draw a 5-degree angle. Now, immediately in your brain, you should be thinking, ooh, a 5-degree angle? That's little. That is acute. This is going to be a really small angle. Now, when I go to draw an angle, here's what I'm going to do. I'm going to lay my protractor down. I'm going to come right here to the middle. Some protractors have a nice little hole that you can stick your pencil through and draw the dot. This one doesn't. So I'm just going to come to the middle, right under the point, and I'm going to draw a line right along the bottom of my protractor. Now I'm drawing an acute 5-degree angle. So I'm going to come over here. I almost forgot one step. Now that I've drawn my line, now I'm going to line up the vertex of my protractor. I'm going to put that line that I just drew, that's going to be my bottom ray, and I'm going to line it up with the bottom of my protractor. So let me do this again. I'm going to draw a straight line. In fact, I could draw it all the way across here if I wanted to. This is going to become my vertex. I'm going to line it up with that same little mark that I used when I was measuring. I'm going to line it up with that same mark on my protractor, and then I'm going to see if I can find 5 degrees. Well, it's not marked on here, so I have to think to myself, well, 5 degrees is halfway between 0 and 10, and so I'm going to come over here. You can hear my cat back in the background. That's fun. And I'm going to see if I can find where 5 would be. Well, 5 would be halfway between 0 and 10. So it's going to be right about here where that little line is. So I'm going to come out and I'm going to make a mark where I think 5 degrees is. Then, my friends, I'm going to play connect the dots. So I'm going to connect the dot for the 5-degree mark with the dot for the vertex and draw through it. Put arrows on my rays, and that is my 5-degree angle. Let's try another one. Let's try 27 degrees. Again, 27 degrees is going to be acute because it's less than 90. So I have to make sure that when I'm done, my angle, it's acute, just like I said it was, and this one was. So this one is going to also have to be acute. Now, what do you think? Do you think that this 27-degree angle is going to be slightly bigger than your 5-degree angle? You're right, it is. So I'm going to come over here. I'm going to draw my 27-degree angle. This time I think I want to make it open this way. So I'll show you how that's done. So let me draw my bottom ray. Doesn't matter how I do it. I want this one to open up going this way. So I'm going to make a vertex over here. And I'm going to line up the center of my protractor, the bottom ray lining up with the bottom of my protractor. Now I'm looking for 27. All right. Let me start counting. 0, 10, 20, 30. Oops, that's too many. Let me go back to 20. Halfway between 20 and 30 is 25. So that means 2 more marks. That should be about 27 degrees. Then I'm going to play connect the dots. I'm going to connect my vertex with my dot at 27 degrees. And I'm going to draw my second ray through them. Remember, I was looking for an acute angle. This definitely looks acute. It's less than 90 degrees. I'm going to mark my arc. And I didn't really have space to do this in my last one, but I'm going to put 27 degrees. So you can see the difference between a 5-degree and a 27-degree angle. A 5-degree angle is much smaller. It's like a pair of tweezers. 27-degree angle is starting to look like a piece of pie. So if this was Grandma's chocolate pie, would you want 27 degrees of it or 5 degrees? I think I would want 27 degrees for sure. All right, let's draw an obtuse angle. I think what I'm going to do is draw this one. This one tells me I'm going to draw a 132-degree angle. This one's definitely going to be obtuse, so I'm going to write that over here. Just so I can get my brain in gear. I don't want to pick the wrong number. on my protractor. I'm going to draw my bottom ray. Okay, I think this time I'm going to want this to be my vertex. So I'm going to make my bottom ray. I'm going to match up the center of my protractor with my vertex. Okay, now, oh, I see 130, I see 130, 132 must be right here. I want you guys to think with me for a second. Is this correct? Because if I draw an angle, it's going to look like this. And I have already told myself that 132 degrees is going to be obtuse. If I draw an angle that looks like this, does that look like an obtuse angle to you? It doesn't. It looks like an acute angle, and that's because it is. Let's see what I was doing wrong. What I was doing wrong is that I was not looking at the correct number. If I draw a dot right here, this is really going to be a 50-degree angle. That is not what I'm going for. So I'm going to see if I can find 132. I know it's not on this side of the protractor. Let's see what happens if I come over here. All right, there's 130, there's 120. So 132 means I'm getting bigger. So I'm going to come to this side of 130, and I'm going to mark 2 ticks over. Then I'm going to come back, draw my second ray, and wow, look at this piece of pie. This is a huge piece of Grandma's pie. Let me just double check and make sure that this is 132 degrees. Definitely looks obtuse. And when I get my protractor here, I can see that this ray goes a couple of ticks past 130. It also goes a couple ticks past 50, but I know it's not 50 because there's no way that this big of an angle is 50 degrees. 50 degrees is an acute angle. This is definitely an obtuse angle. So I'm going to go with the measurement 132 degrees. Now guys, I wish we were doing this in school. This is so much fun to teach, but we're not. And even if you're just watching this, you're learning. If you have a protractor at home or you want to order one from Amazon, go ahead. You can do it. This is just something a little extra that I wanted to show you because it's what we would be doing in school. Now this week, you are going to play games like alien angles. You're going to do some stuff like that just to help you start thinking of and measuring angles. You're going to be able to see angles on a protractor. And some of that is not in our Eureka book, but this is just a supplemental video to give you an idea of what it's like to measure and draw angles if you have a protractor at home. If you do have one and you want to try some of these, I would love for you to send me some pictures of your work. And if not, that's okay. What we're doing this week, it will be enough. Thanks for tuning in, mathematicians. See you later.